Just got back from a week in San Jose where I was at NVIDIA GTC, where I think maybe the narrative at times kind of got lost. Now, Jensen is brilliant. This man is a super brain. He's running the largest company in the world in terms of market cap. And he goes on stage with no teleprompter in front of millions of people and gives this speech. And I think at times, again, with all due respect to this gentleman, kind of loses the overall narrative and the why of what NVIDIA is doing. And right here, he's given the agentic AI talk. He talks about test time scaling and compute, the long thinking, reasoning. And that's the crux of what he's getting at with all of this. He needs to drive, as a publicly traded company wanting to push sales, utilization of more GPUs. I mean, the H200s had just come out, and now he's already talking about the Vera Rubin in the second half of 2026. So what is the whole thing? I was very surprised, and maybe I shouldn't have been, about the whole open source talk. I mean, even here, Agent IQ, Cosmos, BioNeMo framework, whatnot, and then there's a big library of it. And even here, I already have in my hands, it was just announced, Agent IQ, which is a developer toolkit to be able to build and deploy agents. But not only that, but able to evaluate them right here. So evaluation results written, so I can go in here, and it's all open source as long as you have an NVIDIA GPU and you're in the ecosystem. And fortunately for me, I was able to get my hands on a 5090 because they had limited releases, and I saw the truck and I got my hands on it. And right now I'm dealing with Ubuntu drivers and power and everything else that people have already spoken about with the issues of 5090. But that's besides the point. So they mentioned that. They mentioned Omniverse and Cosmos being able to train and develop synthetic data, which again, if you hear generation, you're talking about needing more GPUs. So putting out there really cool things that require additional hardware. And before, I do want to give and pay homage to Vera Florence Cooper Rubin. I think this is something that really cool that NVIDIA does as far as paying homage by naming these thought leaders and these amazing individuals of science. And so Vera Florence Cooper Rubin was an American astronomer who pioneered work on galaxy rotation rates. Here, this is the most important. These results were later confirmed over subsequent decades. Her work on the galaxy rotation problem was cited by others as evidence for the existence of dark matter. Her legacy was described by the New York Times as ushering in Copernican scale change in cosmological theory. So shout out, you badass, Vera Florence Rubin, rest in peace, passed away in 2016. So the next iteration of hardware, beyond even just announcing NVIDIA Grace Blackwell 200 NVL72 supercluster, which I got to go to the Supermicro booth. This is a company that I work with in my actual job. And you can see here per tray, 4 Blackwell GPUs, 2 Grace CPUs. Then in the middle here, you have the NVL switches, which by reference, if I do GB200 NVIDIA, it generally comes, okay, this is all going to be the MGX system. Let's say H200, for example, usually came in this form factor, this big boy, which I believe is 4 rack units versus the singular rack units now that we're looking at per tray. So densely compacting, which requires more power, which now requires absolutely liquid cooling, and the ability to get GPUs into data centers to run all of these generative workloads. I also want to touch on, so Jan LeCun gave a speech talking about physical AI, needing persistent memory. Again, this is all about needing an accelerator, needing computations. And people do kind of see him as a bit of a hater. We are not going to get to human level AI by just scaling up LLMs. This is just not going to happen. And I think this is a concept that's not well agreed upon, but I understand it. I mean, the whole talk here was the amount of tokens needed to generate reasoning and thinking. But for Jan LeCun, the big thing he's discussing, and which was discussed here, is all about physical AI. And physical AI needs to run inference at the edge, needs to act in real time, and needs advanced reasoning capabilities. Perhaps LLMs are not it at the moment, but I'm sure whatever it's going to be, here's this synthetic generation of data, is going to be running on NVIDIA accelerators and whatnot. So they are having that kind of discussion somewhere around here is about quantum. Perhaps that's going to be the next iteration. But yeah, this is all it was about. NVIDIA needs to drive the adoption of AI, generative AI specifically, because a lot of the traditional machine learning can run just on CPUs, and then have the hardware ready to go. So I think as far as the timeline in relative terms, the industry and enterprise, just based on my own experience, is back here. And then Jensen and team has to look so forward and then get people from point A to point B by releasing things like these open source libraries, NIMs, and giving developers the ability to deploy things quicker, faster, safer, more secure, and more useful.